So, you want to know how it all began? It's the biggest story of all time, the story of everything. Imagine, for a moment, that you could rewind the entire universe. You'd watch galaxies fly back together, you'd watch stars collapse into gas, you'd watch all of space shrink. If you could rewind all the way back about 13.8 billion years ago, you'd find a moment when everything was squeezed into a point. Every star, every planet, every person, every single thing you've ever known. This point was smaller than the period at the end of this sentence. It was incredibly hot and unbelievably dense. This wasn't an explosion in space, it was the explosion of space itself. This was the Big Bang. Let's be clear, the Big Bang wasn't a firecracker going off in an empty room. Before the Big Bang, there was no empty room, no space, no time, no nothing as we understand it. The Big Bang created space and time. The universe burst forth from that point. It started expanding, and it has never stopped. This ongoing expansion is the engine of our cosmic origins. Think of a loaf of raisin bread. The dough is space, the raisins are galaxies. As the dough bakes, the raisins move farther apart. What happened right after that initial bang? The universe was a wild and crazy place in its first second of existence. We're talking about a fraction of a second here. In an instant, the universe went through a period called inflation. It expanded faster than the speed of light, growing from something smaller than an atom to bigger than a grapefruit almost instantaneously. This wasn't a gentle expansion. A cosmic growth spurt of unimaginable proportions. Rapid stretching smoothed out the universe, making it incredibly uniform, observable today as the cosmic background radiation. After inflation, things cooled just enough for the fundamental forces to separate. Imagine a soup so hot all the ingredients are blended together. As it cools, flavors become distinct. That's what happened with the forces. Gravity, strong nuclear force, weak nuclear force, electromagnetism. Meanwhile, a sizzling hot particle soup filled the universe, quarks, electrons. The soup was a cosmic battleground. For every particle of matter, there was a particle of antimatter. Matter, antimatter. When they met, they annihilated into pure energy. Yet there was a tiny excess of matter. About one extra matter particle for every billion pairs. That tiny imbalance is why we exist. At 1 second old, quarks began sticking together. They formed protons and neutrons which make up every atomic nucleus today. For the next several 100,000 years, the universe continued to expand and cool, but it was still a very different place from the one we see today. It remained a thick, glowing fog. Why? Because it was still too hot for atoms to form properly. Protons and electrons were whizzing around as separate particles in a superheated plasma. Light particles, called photons, couldn't get very far. They would travel a short distance, bump into a free-floating electron and get scattered in a random direction. The entire universe was like being inside the thickest fog imaginable, a place where you couldn't see anything at all. This cosmic game of pinball continued for about 380,000 years. During this time, the universe kept getting bigger and bigger, and as it expanded, it cooled down. Think of it like a can of compressed air. As the air escapes and expands, the can gets cold. The universe was doing the same thing on a cosmic scale. Eventually, it reached a critical milestone. The temperature dropped to about 3,000 degrees Celsius, which is cool enough for things to change dramatically. It was no longer too hot for electrons to be captured by protons and neutrons. This was the moment of recombination. The free electrons were finally captured by the atomic nuclei, forming the first stable neutral atoms, mostly hydrogen and helium. This was a game changer for the universe. After the universe became transparent, it entered a period known as the Cosmic Dark Ages. This might sound mysterious, but it's actually quite simple. The initial bright glow of the Big Bang had faded. There were not yet any stars to light up the cosmos. The universe was filled with vast, dark clouds, hydrogen-helium drifting silently through expanding space. For millions of years, the universe was dark, quiet, relatively boring. But beneath the surface, something incredible was getting ready. Gravity was at work, quietly and patiently. The universe wasn't perfectly smooth. The baby picture, the cosmic microwave background, reveals tiny density variations. Some areas were just a little denser than others. Gravity began to pull on those regions. Over millions of years, it gathered more gas into clumps. Clumps grew bigger, their gravity strengthened, attracting more gas. The rich get richer. Small clumps became massive clouds. As hydrogen and helium clouds grew, pressure and temperature at their centers skyrocketed. Eventually, a core became so hot and dense that nuclear fusion ignited. The very first stars were born, bright, massive blue giants. About 200 million years after the Big Bang, the cosmic dark ages ended. The first stars were cosmic rock stars. They lived fast and died young. Because they were so massive, they burned through their nuclear fuel in just a few million years. Their deaths were as spectacular as their lives. They exploded in brilliant supernovae, the most powerful explosions in the universe. These explosions scattered new, heavier elements into space. Inside the fiery hearts of these first stars, hydrogen and helium fused into elements like carbon, oxygen, iron. These are the very elements essential for life as we know it. The universe was no longer just hydrogen and helium. It was becoming enriched with the building blocks of complexity. These supernova explosions did more than just seed the cosmos with new elements. The powerful shock waves they sent out into space, compressed nearby clouds of gas, triggered the formation of new stars. This next generation of stars was born from gas now seasoned with heavier elements. Our own sun is one of these later generation stars, iron in your blood, calcium in your bones, forged in the heart of a long-dead star that exploded billions of years ago. We are, quite literally, made of stardust. This cycle of star birth and star death is the engine of cosmic creation. Gravity continued its relentless work on a much grander scale. The first stars were born in large groups, held together by mutual gravity. These clusters began to merge. Over hundreds of millions of years, these collections grew larger and larger. Fast forward several billion years. The universe is now filled with mature galaxies, including our own beautiful spiral galaxy, the Milky Way. About 9 billion years after the Big Bang, in a quiet, unremarkable arm of this galaxy, a new story began. It started with a vast, cold cloud of gas and dust. This cloud, called a molecular cloud, was many light years across. It was composed not just of hydrogen and helium, but also of heavier elements: carbon, oxygen, iron, silicon. These elements had been forged in previous generations of stars and scattered across the galaxy. Something disturbed this peaceful cloud. Perhaps it was the shock wave from a nearby supernova explosion. A part of the cloud began to collapse under its own gravity. As it collapsed, it began to spin faster and faster, just like an ice skater pulling in their arms to spin more quickly. Over 99% of the material was pulled toward the center. Pressure and temperature at the core rose dramatically. This dense, hot core was the protosun, the baby star. The remaining material, a tiny fraction, didn't fall in. Because of rotation, it flattened into a vast spinning disk around the protosun. This was the protoplanetary disk, like a giant cosmic pizza dough being spun around our young star. The disk was thousands of times wider than the Earth-Sun distance. Within it, the journey of the planets began. In the hot inner region of the protoplanetary disk, where the sun's solar wind had blown away the lighter gases, only rocky and metallic dust grains remained. These tiny grains began to stick together through static electricity, like dust bunnies under your bed. Small clumps formed larger clumps. This process is called accretion. Over time, these clumps grew from the size of pebbles to boulders to mountains. These mountain-sized bodies, called planetesimals, were the seeds of the rocky planets. There were thousands of them, all orbiting the young sun in a chaotic dance. The next stage was a cosmic demolition derby. These planetesimals began to collide with each other. Their orbits crossed, and gravity pulled them together in violent impacts. Some collisions shattered the bodies apart, others caused them to merge, creating even larger objects. Over millions of years, this process cleared out the inner solar system. A few large bodies emerged as the winners of this gravitational competition. These were the protoplanets, the precursors to Mercury, Venus, Earth, and Mars. Our own Earth was formed through this violent, chaotic process of accretion. Early Earth was not the peaceful blue planet we know today. It was a molten ball of rock, constantly bombarded by leftover planetesimals and asteroids. The surface was a glowing, red-hot ocean of magma. During this molten phase, the heavier elements like iron and nickel sank toward the center of the planet. One of the most significant events in Earth's early history was a colossal impact. After its fiery formation, the Earth began to cool. The constant bombardment from space lessened, volcanic activity released trapped water vapor, comets delivered water, asteroids delivered water. This water vapor condensed and rained for millions of years. Basins filled, the first oceans formed. By about 4 billion years ago, Earth was a global blue ocean. The stage was set for the origin of life. The early oceans were a primordial soup, rich in chemical compounds. These chemicals came from volcanic vents on the ocean floor. They also formed from reactions in the atmosphere sparked by lightning, and chemicals were delivered by meteorites. simple organic molecules began to join into more complex structures. Some of these structures learned to make copies of themselves. This was the spark of life. The first life was single-celled like modern bacteria. For billions of years, microbes were the only life on the planet. They lived in the oceans, slowly changing the world around them. One group, cyanobacteria, developed photosynthesis. They learned to use sunlight to make food and produced oxygen as a byproduct. Gradually, these tiny organisms began pumping oxygen into the atmosphere. The Great Oxidation Event transformed the planet and was catastrophic for many early life forms. Oxygen enabled the formation of an ozone layer that blocked harmful UV. With UV shielded, life could move from the oceans onto land. Over hundreds of millions of years, single-celled life gave rise to multicellular life, and eventually that long story led to us. So here we are. We've journeyed from a point smaller than an atom to a universe filled with 100 billion galaxies. We've seen stars ignite, galaxies form, and a small blue planet come to life in a quiet corner of the Milky Way. Every step of this 13.8 billion year story was necessary to get to this moment, right here, right now. The Big Bang wasn't just something that happened a long time ago. We are living inside its consequences. The expansion that begun in that first instant is still happening. Galaxies are still moving away from each other as the fabric of space continues to stretch. Think about the atoms that make up your body. The hydrogen in the water you drink was forged in the Big Bang itself. The carbon that forms the backbone of your DNA, the oxygen you breathe, and the iron in your blood were all created in the cores of massive stars that lived and died long before our sun was born. Those stars exploded, scattering these precious elements across the galaxy, and they eventually became part of the cloud of gas and dust that formed our solar system. You are not just living in the universe is living in you. This cosmic perspective is, I think, both humbling and empowering. It's humbling to realize our planet is just a tiny speck in an incomprehensibly vast cosmos, and that our lives are just a fleeting moment in cosmic time, but it's also empowering. We are the product of an unbroken chain of events stretching back to the beginning of time. We are a way for the cosmos to know itself. So the next time you look up at the night sky, don't just see a collection of twinkling lights.